If you drop a ball, it falls to the ground. What is the reason for this? In the dynamics course, you will learn that objects fall to the ground because of the force of gravity exerted by the Earth on all objects near its surface. This gravitational field strength around the Earth is strongest at the surface of the Earth, and it gets weaker as you move away from the Earth. In the absence of air, that is, without any air resistance, the object will fall only under the force of gravity exerted by the Earth on the object. We term this as free fall. Scientists have discovered 4 very interesting and important facts about objects falling to the ground in the absence of air resistance. That is, when they free fall. First, objects fall at increasing speed. That means they accelerate as they fall. We often do not notice this because objects fall so fast. But if we were to drop an object from a very high altitude and measure the distance it travels over time, we will discover that its speed increases as it falls. In other words, it accelerates as it falls. In fact, the second interesting fact that scientists discovered is that this acceleration due to free fall is a constant at around 10 meters per square second for objects near to the surface of the Earth. This means that if you were to drop an object in a vacuum room and measure the distance traveled for each second so that you can calculate its velocity, you will discover that after each second, its velocity increases by 10 meters per second. And if you were to plot these velocities on a velocity time graph, you will discover that it is a straight line with a gradient that is 10 meters per square second. And what is more interesting is that this acceleration due to free fall is not dependent on the size or shape or mass of the object. So if you drop a feather and a flower vase simultaneously in a vacuum room and measure the distance that they fall, you'll discover that they fall through the same distance with each time interval. And that brings us to the fourth interesting fact, that is, regardless of their size or shape, they will both reach the floor at the same time. The acceleration due to free fall, which determines how fast an object falls to the ground in the absence of air resistance, is only dependent on the gravitational field strength of the planet. Different planets have different gravitational field strength. For instance, the gravitational field strength of the Earth is 6 times stronger than that of the Moon. Imagine if you pull an object. If the force is greater, the object will accelerate faster. So when the Earth's gravitational field strength is stronger than the Moon, it means the pull on the object by the Earth is stronger, and hence the object will fall with greater acceleration on Earth than on the Moon. We will cover more on gravitational field strength in the dynamics course. In this lesson, we have studied the 4 interesting facts about objects free falling in vacuum, that is, in the absence of air, and being subjected to the acceleration due to free fall. In our next lesson, we are going to find out what happens when objects fall in the presence of air.